Hello everyone, this is Dr. Ali, and today we want to solve another problem of Reeborg's world, so-called hurdle1. And here's the environment that you can find it in Reeborg's or Reeborg.ca. And the goal is to move this robot and the position 1 and 1 that follow this dotted path and move it to position 113 that this flag exists. So in order to have more information about this game, you can click on this world info and it will give you some brief about what is this about, and it gives you some hints. For example, it says probably you need to use move function and turn left functions and so on. And it also give you this more advanced tip that if you want to make it more professional, maybe you want to define a jump function and go that path. But let us think, regardless of what it says here. Let's see what we can do and what is our intuition for solving this problem. So as you see here, we have 6 different obstacles here, right? So the thing is, if we jump over or step over one of these obstacles, we basically facing the same problem, but instead of jumping over 6, now if you're here in the 1, 3 location, we have 5 more obstacles to jump over. If you're here, you're facing 4 more obstacles to jump over, right? So it seems that if we need to define a function. I call it one step. And the goal of one step is just moving this robot to the location right after this obstacle. For example, right now it is in 1 and 1. We want to move this robot from here to the next cell after this obstacle, which is 1, 3, right? And then we keep doing this till we reach this flag here. So let me define one function here. I call it one step. And then for this one step, first we need to move in the direction of this direction that this robot faces. Right now, the robot's direction is toward right. So we just simply can use, say, move. And when we are moving this robot, it goes from this location 1 and 1 goes to 1 and 2. Then we need to change the direction of the robot from right toward top, right, toward upward. So for that, we need to just simply say turn left. And then the direction now is toward up. Now we need to just move, which means that the robot goes from here to this location, and the face is toward up. Now we need to change the face or direction of the robot again towards right. So for that, we need to have some function turn right, but we don't have it here. If you look at this function, this pre-built function here, there is no turn right. And we can define it here ourselves, turn right. And in any direction that the robot faces, in order to turn right, we can simply use 3 times turn left. You guys can evaluate this, which is correct on your own. But just for example, if the robot faces toward up, right, and then we want to turn its face toward right, this direction, if we use 1 turn left, its direction goes from up to the left. If we use toward left, it goes from up to the bottom, because first left is toward left, and second turn left is change the direction to the bottom or to the down, and then third left is change the direction from up toward the right. Okay, so if I use this turn right, now when we are here, turn right is change the direction of robot toward the right direction, and then I just move. It means right now I'm here and the direction is toward right. Then again I need to turn right. We just turn right, the direction goes toward bottom or toward down, and then move. So when we move, so far, following these functions, I'm here, this robot is here, and its face is toward bottom. So in order to have a same status that we started at location 1 and 1, we need to again use a turn left. So following this is one step, I expect that this robot face is toward right and is located in the position 1, 3. Let's check it if it is work or not. Let me just simply call this one step. And you can use this gear here to run it. So sims goes up, turn right, again turn right, come here. Okay. This achieved the goal that we have, that we wanted to stop here. Of course, it gives us this error because we're not done yet, because the goal is moving the robot from this 1 and 1 position to 130. So now that we know that one step works properly and works correctly, we need to just keep doing this 6 times. So this is just a simple iteration or loop problem, right? So I can say for in range, if I can type correctly, range one step. So basically I'm saying repeat this one step 6 times. Let's see if this works or not. First obstacle passed correctly and goes to the next. And there we go. We reached to this location 113 and the robot stopped. So this is the first solution that we could use. But obviously this is not the only solution. We can solve this differently. So for example, one thing that I don't like about this approach is this 6 here is hard-coded. It means that this function or this way that we solve it, it won't work if there are, let's say, 10 obstacles, right? So how can we make this more generic? And basically, we don't want to have this hard-coded here. And we want the program itself to detect that, okay, if there is a goal or if there is any flag anywhere, then stop there, right? So let me comment this out and show you what I mean. Let's use this. Comment this out now. All right, if we go to these conditions here, we see there is a function at goal. The output of this out goal is a Boolean value that it returns true if in that cell that you call this at goal, there is any flag. If that in that cell that robot exists, you call this at goal function and there is no flag in it, it will return false. So how can we use this function in order to get rid of this hard-coded value? So simply, I can use a while loop and say while not at goal. So as long as I'm not at the goal that I want it to be, then keep doing this one step, right? So one question that I have from you guys is how many times in this environment this at goal function is called, right? So let's think a little bit about it and I will give you a solution. So let me run this while you're thinking and let's see if it works. There we go. We reached from the position 1 and 1 to the 113 correctly and solved the problem. But for the regard to that question I asked, this at goal it will call at before we do one step, right? So it means at the beginning, when we start this for loop or the while loop, basically we call this at goal one time. So here we call the at goal, and again in the position 1 3 we called at goal another time. In the position 1 5 another time, 1 6 another, 1 7 another time, 1 9, 1 11, and 1 13. So in total, this at goal function is called 7 times. So let me know if you have any comment or you need more explanation on the comment below. Otherwise, see you in the next session that I will solve the same problem using recursion function. Have a great day, everyone.